There are many ways we can think of database performance. How much infrastructure is needed, how much it will cost me, how much throughput can it sustain, and under what latencies. The following ScyllaDB monitoring screen shows a small 3-node cluster sustaining beyond 500,000 operations per second, with P99s in single-digit milliseconds and average switching microseconds. What's even more impressive is that the cluster consumes only 70% of its total processing capacity, with more to spare. Every CPU handles over 5,500 operations per second. And another angle we can think of database performance is how fast we are able to scale it to handle additional capacity, which is very important for seasonal and unpredictable periods of traffic. With ScyllaDB, scaling your cluster capacity is just as simple as adding more nodes to your cluster in parallel, just like what we've done here with a single click of a button. ScyllaDB will automatically balance the load in the background until it achieves perfect balance. What's more important is that this exercise, in this example, takes less than 10 minutes to complete. Once that's done, we can observe that the new nodes started to take part of traffic even before the scaling operation actually completed. In other words, if you have a surge in traffic, adding new nodes will help with balancing the load until it eventually converges. Also note the system load. It went down from 70 to 50% utilization. What about latencies? Latencies were kept predictably low, but slightly fluctuated. This fluctuation can easily be explained by taking a look into the cache section within the ScyllaDB monitoring. New replicas joined the cluster with a cold cache, and requests to them took longer. To prevent latency spikes, ScyllaDB heat-weighted load balancing guarantees that requests are routed to primary replicas with a warm cache, and only a small fraction of traffic hits the cold replicas. Switching over to the operating system metrics, we observed that during the scaling operation, network throughput achieved closer to 1.5 gigabytes per second. That's almost 12 gigabits per second, which is really close to the maximum throughput our NICs can sustain. Alright, so we scaled the cluster and observed how the system reacted with additional capacity. It's now time for us to scale traffic. With 6 nodes only, let's reach 1 million operations per second. Look how the system behaves during this scaling exercise. Within the cluster view, we can observe 1 million operations per second with latencies within 3 milliseconds per request. Exactly the same numbers as prior to the scale-out operation. Let's now run another workload in parallel to see how our 6-node cluster behaves. Before we do, what we did was to define another service level for it. A service level is a logical abstraction allowing the user, or you, to specify different priorities on a workload basis. In this example, our 1 million operation per second workloads gets scheduled within the real-time service level, and we basically started a secondary workload with 10 times less priority than our real-time workload. So as we can see, after some time in the monitoring, we started to observe the yellow line showing latencies, higher latencies than our real-time workload. And now let's take a look into the advanced dashboard and see how the CPU utilization compares across those two workloads. What we can see is that ScyllaDB is dedicating 10 times more CPU time to our real-time workload compared to our secondary workload, which gets only 1/10 of CPU time. So we finally get to the last performance angle for today, which is how fast can we scale down our database, save on costs to minimize infrastructure spends, and avoid being over-provisioned. We ramp down traffic, and right after we start to downscale our infrastructure back where it was when we started. Next, we start removing nodes in parallel, and then the reversed process begins. Nodes leaving the cluster start streaming data to the nodes which are remaining, and traffic gets automatically redirected with minimal impact to your running operations. All this entire process takes less than 20 minutes, and basically, folks, this is how fast ScyllaDB is.